The U.S. Department of Energy, DOE, and contractor CH2M Hill Plateau Remediation Company, CHPRC, are reducing risks in the 300 area of the Hanford site in Washington State. The 300 area is located along the Columbia River, just north of the city of Richland. This area supported the site's nuclear weapons production. Workers have demolished many of the contaminated buildings and cleaned up much of the contaminated soil that had resulted from work conducted in the 300 area. DOE and CHPRC are now addressing the challenge of removing highly radioactive soil discovered beneath one of the buildings during demolition. Crews at the 324 building are preparing to remove the highly contaminated soil below the building using only remote-operated equipment, cameras, and lights to guide operators. A team of well-trained personnel will accomplish this complex work using the lessons learned from the training and proficiency they gained on the equipment at a non-radiological, full-scale mock-up. The 324 building is divided into an airlock that connects 4 hot cells, including A, B, C, and D, with C cell located beneath D cell. The contamination is under B cell. Engineers developed specialized tooling and remote-operated equipment for use in that highly radioactive environment. CHPRC will augment the B cell foundation to ensure the excavation of the soil underneath does not affect the structural integrity of B cell. Workers will conduct excavation using remote excavators, which will hammer, cut, and dig out the floor of B cell to access the highly radioactive soil beneath. A specially designed, removable airlock rail and cart system will transport items in and out of the airlock. Crews will use existing facility cranes to install the equipment. The remote excavators will use several interchangeable tools to remove grout and debris, score and remove the existing floor, and excavate the soil underneath. Waste determined to meet the requirements for safe transportation and disposition can be shipped to the Environmental Restoration Disposal Facility located at the center of the Hanford site, which will ensure the protection of the public and the environment. Workers will stage the remaining radioactive waste from B cell in the surrounding cells and grout it in place. Workers will break up the existing 6-inch grout cap in B cell using a remote-operated hammer tool. Crews will remotely remove the remaining debris and transfer it to A cell. Following grout and debris removal, workers will cut the B cell floor's stainless steel liner and score the 6-inch thick concrete floor into segments for breakup and removal using an engineered, remote-operated floor saw system. Workers will transfer floor segments from B cell to A cell and later encapsulate it in grout to provide radiation shielding and contamination containment. Crews will use a second remote excavator for soil excavation, which will work in tandem to load waste bins that will be transported into the airlock using an engineered transfer mechanism. They will also excavate the highly contaminated soil beneath the B cell footing to ensure that all highly contaminated soil is removed. When removing the soil, workers will target the most highly radioactive materials found around the perimeter underneath the former B cell floor. Once they remove the highly contaminated soil, they will stabilize the excavated area, preparing the 324 building for future demolition. Removal of the highly contaminated soil beneath the 324 building will stabilize the facility and protect the Columbia River, reducing the risk to human health and the environment and taking one more step towards cleanup of the Hanford site.